All right, we're there. So the normal, this is how they can ask for a derivative. Shh. They can say differentiate, they can say instantaneous velocity at blah, right? They can say that stuff. But they can also do this. If they give you the equation as y, the derivative of that is y prime. If they give you the equation of y, you could actually write dy over dx. These are the two different forms that, depending on which your prof likes better, they will use, just so you know. I like the prime better, but they can do what they want. This one's called Leibniz notation. I'm assuming Leibniz was the person who made it. That is not that. And I'm not sure if I'm saying it right, but I know for a fact you're not. So, this and this are the same thing you could use if you had a y equals. If you have f of x, you would write it as f prime of x, which we've used a few times. Okay? Good talk. All right. Then there's this. We could use this lovely formula, but we're going to say not today anymore. We're done. Okay. So we're going to go here. Power rule. We're so good at this one. So this is the definition of power rule. So we can do y prime, or if we use d over dx, if they go like this and they go d over dx, x of n, this means the derivative with respect of x of n. So if the variable was a c, let's say, you would go d of d over c of c to the n. And then you would know that c is the variable, like x is the variable. Okay? So the good thing about using the d over dx is it literally tells you which is the variable. Because sometimes what they'll do is they'll go like mx squared plus 2x. And then you're like, because it's x, you're like, it must be the x that's the variable. Or you're like, I don't know what the m is. Or they'll go plus c at the back, right? So if they go d over dx, then you know for a fact that m is just a number and so is c. They're just a variable that's used for any number in the sun, under the sun. In the sun, there's no numbers in the sun. Okay, good talk. Exemple 1. Exemple 1. I don't know why I did kind of a little bit of French with a little bit of English there. Find the derivative of each of the following functions. So, it shows it up here that we take the n, drop it in front, and then reduce it by 1, right? This is just the general form of power rule. You can always use power rule when variable to some exponent, that is a number. Variable to some exponent, that is a number, correct? If I have number to a variable exponent, can't use it. If I have variable to a variable exponent, can't use it. So the only way I can use it is if I have a variable to an exponent by itself, can do power rule. Okay? So we're going to do the first one. So it's f of x, so we're going to write it as f prime of x. Now what do we get? 3 drops to the front and joins the 5, and we get 15x to the weak. Okay. That was always make me feel like I'm funny, but that wasn't even very funny. Okay, now we bring the 2, we drop it in front, and what happens?
Negative.
You get a negative 1, because 2 times negative a half is negative 1. U to the 1. Do we have to write the 1? No, but I'm a rebel, so I'm leaving it like that. Now, this one. We have u of x. So that tells me what's my variable. X. Anything else that's on there? Was a p, a c, anything like that? It's going to be a number. That just can be any number, correct? So we're going to do u prime of x equals. Now I take the 3, I drop it in front because pi to the 4 is just a really nice number of some sort that doesn't stop. Right? It's 3.14159 to the 4. Okay? And what's going to happen is I'm going to multiply it by 3. So I'm just going to write it as 3 pi 4 x to the 2. Done. What about d? F prime of x equals 6 x to the 1, which I don't have to write. And then what happens to the 8? Goes away. And the reason why it goes away, as a reminder, is 8x to the 0 drops in front, multiplies by 8. 0 times 8 is 0. This goes to a negative 1, but 0 times that is all just gonzo alfonso. So whenever you take the derivative of a constant, gone. Poof. Magic. Like Hermione. Yes. Magic. I should put my wand on this. I I don't. My daughter has a Hermione wand. She also has a Hermione wand pen, and she has another one that is not a Hermione wand. But if I went poof, wouldn't that have made that so much better? I'm going to steal that wand. That's where my head's at. All right. E. This is irrational. When it's irrational, you cannot do power rule. But it's in the power rule section, so I must be able to, right? So, if your numerator or your denominator is just a number, you can split it up and then not have it all over a fraction, correct? So, remember I told you guys are really good that if it's common denominators, you slap it together and you have a full fraction, but you forget that you can actually separate them back out. So I can just write both of these over what? 9. So I'm not going to write f prime because I have not done anything. So f of x is 1/9 x 7. So instead of writing it over 9, I'm going to write 1/9 because it makes it easier. Minus 5/9 with an x to the 1. Now is it in a format that I can actually do power rule? Yes. So now I can write f prime of x because I'm actually doing the derivative. Bless you. So I get 7 times 1/9, which is 7/9, x to the 6. And then I go 1, drop it in front, negative 5/9, x to the 0. What happens when we get an x to the 0? It's just 1. So not only when we have a constant does the constant drop off, whenever we have anything that's actually to the degree 1, it's just going to, x is going to go away and we're just going to be left with its coefficient. Okay? Okay. There's these ones, but I'm only going to assign them on Monday, so you can get ahead if you really want to. Okay. I scoff at your getting ahead. You're AP. You're supposed to be wanting to do this right now. What? Okay, it's better. Okay, I want you guys to do A, and then I want you to do B. What does B mean?
Substitute whatever you get f prime of x.
Yes, so substitute the 2 into f prime of x. It wants the first derivative at 2. So I want you to do A and B. Go. So f prime of x equals 8x to the 3. 2 drops in front, negative 12x to the 1. The 2x turns into a 2, and the 3 goes bye-bye. So when you do a polynomial, just so you know, if you start with a degree 4, you're always going to drop it by 1 degree, right? So you're going to end up with a degree 3 on your quadratic. On your quadratic. Yep, on your derivative. Okay. Then I want f prime of 2. What does f prime of 2 actually represent in math, in calculus? The tangent slope when x is 2. Yeah. Or instantaneous rate of change if this was a distance equation. Instantaneous velocity. Okay. So we're going to plug it in, and we're going to get, that's an equal sign, although it doesn't look good. 8, 2 cubed, minus 12 times 2, plus 2. 8 times 8, 64, minus 24, plus 2 is 40. Thank you. So the slope at 2 is just rising 42 over 1. No big deal. MBD. That'd be easy to draw. I scoff at that. Okay. C wants you to find the slope of the tangent line at 1 and negative 5. So what are we going to have to fill in this time? What do they actually want you to find? The slope at 1 and negative 5. F prime of 1. So they want you to find f prime of 1. D, they want you to get the tangent line at that. And C, they want, or E, they want the normal line at that. F, they want you to graph them. Go. C, D, E. Remember, normal line is the perpendicular slope, right? So negative reciprocal. So whatever you find in C, you're going to flip and negate for E. Times 1. That was aggressive. I didn't mean for it to be that aggressive. It got the point, though. It understood. Okay. 8 minus 12 plus 2 is? Yeah. So it's still a nicer slope to draw, because we would go down to right one or up to left one, right? I'm going my left, your left would be that way. All right, then we need the equation of the tangent line. So we have, I gave you one in -5. Most often they'll give us the x but not the y. How do we get the y? Always plug back into the original, because you need to coordinate off your original. Okay? So we get y minus a minus 5 equals m, which is -2, x minus 1. So if they just ask for the equation, this is the fastest one, right? You don't have to do any work. It's the y minus y1 equals m times x minus x1. Now, if you did it in y equals mx plus b, you're fine. But I'm just going to show this one in expanded form. It should match yours. So -2x plus 2 minus 5. You have to subtract 5 over. So you'd get -2x minus 3. If you wanted to just type it into your calculator, would you actually have to expand this bracket? No, you could just write it with the bracket minus the 5 over and put it into your y equals, right? E wants the normal line. So if m tangent equals -2, m normal equals positive a half. Now I would do y minus a minus 5 equals 1/2 x minus 1. Once again, you can subtract 5, you can type it in. Look at it. There's lots of questions there. Okay, this one says, let's be our last one we're going to do today anyways. And then, do I want to do B yet? Nah, I'll just do A for now.
In y equals mx plus b form, what would the m normal be?
1/2. Your m normal doesn't change, no matter what format you put it in. It's your m.
Yeah, I got that. I mean, like, what would the actual equation be with y equals mx plus b form?
Distribute the half through. Be minus 5.5, so minus 11.5. And there's an x in there.
So you basically have to, oh yeah, that makes sense.
Can't see what you're thinking, but
Don't worry about it.
I'm with you. Exactly. Totally. I agree. Okay. So this one here, it says find the points on the graph of this where f of x has a horizontal tangent line. Tangent line means first derivative. Horizontal means what's the slope at horizontal line? 0. So we want f prime of x equals to 0. So whenever they want what points where are their horizontal tangent lines, we're going to set the first derivative equal to 0 because the tangent slope of a horizontal line would be 0. Okay? All right. So we have to first find f prime of x because we can't set it equal to 0 because we don't have it. So f prime of x equals 3 drops in front, 12, x to the 2 minus 2 drops in front, 24x. And what happens to the 2? Oh, the wand would be so good. Poof, down. Okay. Now, f prime of x equals 0. And now I just need to solve. How do I solve this? Pardon? You were right, I believe. I think. I heard really quietly. Yeah, take out a 12x. So we take out a 12x as our GCF, and then we're left with x minus 2. Now remember, the 12 is in its own brackets and the x is in its own brackets, correct? So what would our two answers be? X equals 0 and x equals 2, but they want point. It should say points. That should have an S, or at least a bracket S. Bracket. But those are not points. So some people be like 0, 2, comma. Perfect. Which one comes first? I'm like, no. How do we get the actual points? Put it back into the original. Yes. When we have an x, we need a y, put back into our original. So we're going to go f of 0 and f of 2. So we go 4 times 0 cubed minus 12 times 0 squared plus 2 equals 2. So we have 0, 2 is one of our answers. And then 4 times 2 cubed minus 12 times 2 squared plus 2. 8 times 4 is 32. 4 times is negative 48 plus 2. It's 34 minus 48, which is negative. Now, I want you to see what the heck this actually is. So we just found out where the horizontal tangents would be, did we not? Horizontal tangents would be at 0, 2, and a horizontal tangent will be at 2 and negative 14. I want you to type this bad boy into your calculator. I don't want crayon. I want highlighter. Guess crayon is an option. I want you to type this into your calculator, please. I should use crayon, but I'm not going to because I'm not a rebel today.
Well, you were before.
I'm a sidetracker is what I am today. If the sidetracking is strong.
That's just a different kind of rebel.
Really? Yeah.
So you're still a rebel.
Except I have no control over this. Seems to be today I have no control over my sidetracking. It is the min. Oh.
I already knew that.
We just found the minimum and maximum without using our calculators. We've never been able to do that. Wow. Almost like wout. Wow. I thought she said wout at first, but she said wow. We literally just found the min and maxes without our calculators. Remember I told you that on the diploma with 30-1 that you didn't have to write because somehow you guys lucked out. I told you that they can't make you find the max and mins algebraically, that they can only make you use your calculator because you'd have to have the first derivative in order to find them. Here's that moment. You're welcome. Okay.